All right, guys, thanks so much for joining. Today it's OUDP Leakage with Olsen. And so we'll get started. Just to kind of a couple of things, here our mission at the Rocky Mountain chapter is to be the best chapter in the world by enriching the lives of our members through ongoing growth, development, and connectivity. You're chapter of the year in 2021. I know CLC is kind of wrapping up, so interested to hear all the different awards that happen there, but we're always trying to be better, and we've got a really great community here in the Rocky Mountains. Just a couple notes about membership. There's different ways at Comcast you become a member, and I know at Charter's got a lot of different ways. If you've got any questions, please reach out to any one of us on the board, and we're happy to help you in renewing. It's very important every year. I know people sign up in prior years and think it auto-renews, but it really doesn't. So please reach out to us if you need any help. We also like to bring up, as a chapter member, we do pay for certifications. And so we really want to encourage the growth of knowledge. It helps kind of elevate your career, network. So please reach out to us as well if you're interested in getting certified. And again, the certifications range from anything from an installer up to an engineer, head end. So lots of different options that we're here to help cover for you. And again, you can also reach out to us. We've got different platforms to reach out individually to any of us. Just let us know. So today, our guest speaker, Olsen from Viavi. Eric is a 40-year veteran of the cable TV industry. The last 20 years, he's been with Viavi, helping our customers gain efficiencies by using data from instruments and probes to monitor and better understand their networks. Most recently, been involved with the return path monitoring, DAA implementations, and high-split networks and fiber monitoring. So I will let Eric get started. I'm interested to hear his presentation today.
All right, very good. Well, hello, everybody. As Gretchen mentioned, my name is Eric Olsen. I'm with Viavi Solutions. I'm in our North American team that supports our cable operators. Also joining me today from Viavi is Dan Dillon and Mark Dara. They'll be assisting. They're longtime experts in leakage, and we'll be able to help answer any questions that we might have, anybody might have at the end. So I appreciate everybody coming today. Let me give a quick overview of what we're going to kind of go through. I want to do a little bit of a background on leakage detection, Ingress and Egress, and what it is. I am not going to try to go into a lot of the details associated with, like microvolts per meter and how exactly you locate a leak. What we're going to be focusing on is the changes that are coming about as a result of going to high splits in the networks. And looking at how that, why we have to make changes, how that affects how we do things going forward. Explain a little bit about what this thing is everybody's been hearing about called OUDP. What is that, other than a little bit of acronym soup there. So we're going to talk a little bit about that, how this impacts what we do in the field. We're going to have a little bit of a review quiz, so at least try to pay attention, and then we'll open it up for some questions at the end, and it really can be anything related to leakage. So if you have any questions, we'll be happy to go over those and answer what we can. So to kind of give a little bit of background, I want to really start kind of at the very beginning, is why do we use coaxial cable? Coaxial cable, we use it because we reuse over-the-air channels on our networks. So over-the-air things like TV channels, FM radio, Aeronautical, voice and navigation, cellular telephones, cellular frequencies, all this are using the frequencies over the air. Those are licensed services, all right? So they're licensed by the FCC. We are secondary users of those frequencies, right? So therefore, we must not interfere with those primary or licensed users of those frequencies. Literally, by law, we cannot interfere with them. So the way that we do this is what the coaxial cable does for us is all of our signals are carried on the center conductor, the main part of the cable, and then they're shielded by the metallic shield. And what that does is that keeps all of our signals and RF, power and everything inside the cable, and also prevents other ones from coming out, right? So we are using it, and we are preventing, by using the shield, any of those RF energy from getting out of the system. And likewise, we're preventing any energy that's outside, those licensed users of it, from getting into our system. So it's important that we maintain the integrity of this sealed system, of this coaxial cable, so that we don't cause interference and we don't receive any interference. So the ingress is anything coming into our cable system, and the egress is any of the signals getting out of the system. So as we talk about leakage and ingress and the shall we say, the flaws or the problems when you have that sealed system is damaged, it can be caused by a lot of different things within the network, right? So you can have, in some cases, obviously cracked, damaged cables can cause it. You can see the center conductor is not shielded at all. The outside shielding is definitely damaged. If you look closely, you can see where part of the outer sheath has been eroded off and taken off this piece of cable, right? So it's leaking probably badly. In this case, you can see that there's a tree that's actually been rubbing on the cable, right? So it's creating a hole in that shield. Once again, it allows the ingress and egress of the of RF signals in and out of the plant. This one's a pretty, you look close at that splitter, look at that center conductor on a drop cable, right? So all these are sources of leakage and ingress and egress within the network. Also, every device that we have in the outside plant is designed not to leak at all, either in or out. And in this case, this leak of water would most likely be causing a leakage of signal within the system. But although these are pictures mostly of the main line, by far the biggest source of leaks, ingress and egress in our network, is actually the drop cable. And it's not just something like this where you have a customer doing some sort of a splice on the wire somewhere, which obviously wasn't done correctly, but it can be things within the home, staples run through the, drops within the house, loose fittings, anything like that can be causing leaks. So we have to, by law, make sure that we are not interfering with other users of the frequencies, and that we're not having our system impaired by outside frequencies getting in. So what does it take to effectively detect ingress and egress? I want to kind of go through the basics of what we want to do, or what we have to do this, and then we're going to talk about what changes as we go forward in the future. So the first thing that we have to have is we put carriers on the network that allow us to monitor the network, all right? Usually there's a carrier in a lower frequency down where the aeronautical band is, and there are carriers in the upper frequency where the LTE band is. And these are the aeronautical, we have to monitor that, so we're down in that area. Upper frequency is making sure we don't have any upper frequencies. There can be more than 2 carriers. There could be 3, 4 different carriers across the band. For the purposes of the discussion today, I'm just going to kind of focus on 2 of them. A lower frequency and an upper frequency. So we have to put carriers on that we are going to monitor. Second thing we have to do is we have to tag those carriers so that we know they're ours. Well, we're putting them on the network, so obviously they're ours. But once they get out of the network, if they're leaking, right, we want to make sure that it's not some outside energy source that we might be picking up with our detectors, right? So we tag the characters, or the carriers. There's a lot of different ways that those can be tagged, but there's something on it, that is telling us this is our carrier and that this is what we need to be troubleshooting and running down if we're seeing that there's an issue. The third thing we need to do is obviously a mechanism to pick up anything that might be leaking out of the system. So some sort of a receiver, right? So you have a receiver, it's going to be actually pick up those signals that are leaking, so pick up that energy that's coming off the network. An antenna is really critical to the process. An antenna not only helps with gain, in other words, I can, let's say from the street, pick up a leak that might be in the backyard, right? So I have the gain of the antenna to help me pick up leaks, but then also for the direction of the leak. So as I turn the antenna, I can decide where is it coming. It's coming from there versus over there, right? So this allows me to get that location of how I narrow in on it. The other thing we need to do is we make use of the GPS system to know where are you when you detected the leak, right? Where was it being detected? this helps us triangulate. So if you happen to drive down one street and then come back on the other and you pick up a leak, where you're figuring out, oh, it's in this common area of the plant, right? So I'm not necessarily creating multiple potential leaks that have to be fixed, but I'm putting them all together. And then it's for tracking purposes. Where did you test it, etc. The GPS helps us know, where you were as we're working on the plant. And then the last piece of it is software system that collects the leaks, correlates them. So you're collecting all the leaks, so it's a leak that was detected. Was it fixed? Was it taken care of at the right time? How strong was it? It was. Correlating those, triangulating them so you know where they were. And then there's reports that are produced. And, primarily two sets of reports. There's usually internal reports within our companies, right? So we're tracking what we're doing, our progress, doing quality control on that. We're making sure the network is tight. But then there's also reports that are required to go to the FCC that are showing that we are actually monitoring the plant and that any significant leaks we've repaired quickly and taken care of. So these 6 things is what makes up what we have to do to effectively detect ingress and egress in the plant. All right, so now we kind of went through kind of what we do. So why is high split changing things? All right, so what is changing? Well, right now, both the aeronautical band and the LTE bands that we're focused on, once again, we could be monitoring more areas in the network. When you have a sub-split or a mid-split system, those bands are in the downstream. So when we're injecting the carriers that we were talking about, we're just putting them in the downstream, and we're able to figure out that we have a leak. We're using our processes to figure out where there might be a leak in the network, either egress or ingress. All right. Now, what happens, though, is when you go to a high-split system, the aeronautical band now falls into the return. It's not in the downstream anymore. It's in the upstream. So the portion of the spectrum that the cable modems are using to transmit, right, to transmit back up to when the data, that is now within a different band, right? They're using the lower part of the band. So this high split forces that aeronautical band into that, into that area that's in the upstream. So now I can't inject a signal, right? So when I move it, the signal, there's no way to originate that from the head end anymore. So therefore, to use any leakage detection system, I have to have something that I'm transmitting the other way in the network to be able to pick up a signal. And in the case of where we're going with all this, the cable modem is a logical thing to use, right? Customers have the cable modems. If it can transmit a signal, that's the signal that I could use to detect that lower part of the band to be able to monitor the aeronauticals. So for the upper carrier, like I was talking, we're originating the carriers from the hub, from the head end, going out into the networks, right? So it's going across all the different branches within the node, right? All throughout the HFC network. And when there's a leak, right, I can pick up that leak with my receiver, and I know that I have a problem, right? So that's happening all the time. All the time I'm transmitting this, right? So that works great, still works great for the LTE or any upper frequencies that I'm monitoring. All right. Now, when I get into the aeronautical frequencies, right, that are in that return path, what I'm actually going to do is the modems are transmitting, right? So they're sending the signals back up the network, right? So I have modems transmitting signals. They're sending it back up the network. And then just like with the upper frequencies, if there's a leak, once again, it gets picked up by that leak, and I'm able to know that I have a problem in the network. It's just that the signal originates basically from the opposite direction in the network, because that's where the modems are transmitting. All right? So we're using this principle of using the modems to be able to do this. So when I bring it all together, I have the downstream going with the upper frequencies. I have the upstream with the lower frequencies. And then either way, when I detect a leak in the network, I can pick it up with my receiver, no matter which one it is. So I have all the origination of these signals going on simultaneously through the network, but for the purposes of the receiver, I'm still picking up and I'm able to localize a leak. All right? So it's kind of bringing this all together, how this works. So now, how do we create a reliable signal from the modems? Because remember, that was one of the things we needed, was we needed a signal that we can rely on. So we need this reliable signal at the correct frequency. And we also have to make sure it doesn't take up a significant portion of the bandwidth, because you got to remember, we're transmitting in the same part of the band that the customers are using for their access, right? So we don't want to be using up any more of that access than absolutely necessary. So this is where we get to our acronym soup, OUDP. OUDP to the rescue. So what actually is OUDP? It's an OFDMA Upstream Data Profile. That's what OUDP actually stands for, all right? And what the OUDP is used for, it's a test burst, and it was designed within the specification as a mechanism for the modem to test the maximum modulation it can support. So it's like a test burst on the network. How fast can I be transmitting? Which profile can I be using to communicate back to the CMTS? This was implemented with the DOCSIS 3.1, and it's supported also in the DOCSIS 4.0 standard, right? So is when this capability came out. So it does require a DOCSIS 3.1 modem to be able to do this. It's enabled by the central controller. So the central controller tells the modems to use these OUDP test bursts, right, to be able to transmit those. So it's telling them when to do that. And then as part of the spec, there are configurable patterns that can be set as part of these test bursts. And these patterns are what we can use to know that this is actually the signal that we're generating that we want to then be looking for across the network. All right? So it fulfills a lot of those needs we have when it comes to be able to do something with leakage detection. So we start using the OUDP burst for the leakage detection, right? So the modems send a burst at a certain frequency with a predefined pattern. And when we see that, that's how we know we have a leak, all right? And then what the controller does is it round robins through all the modems in the node, telling them to burst at different times, right? So the modems are not all bursting at the same time. They're doing it at all different times, and they're bursting across the node, all right? So it's literally across the node you're hearing these bursts, right? As they do this, and then in any point on it, I can pick up these leaks. So what changes are required so that we can support this? Okay, so we can detect these bursts. All right. Well, quite frankly, the beauty of the solution is that not a lot has to change. Now, you do need to have, because rather than a conventional tag, the receiver must recognize the OUDP burst pattern that's configured. All right. So depending on the receiver, it probably needs to be a newer receiver that has this capability to detect the OUDP burst and the pattern that you've configured in your system. Right. So you would tell it I'm using this, tell the frequency you're going to be using it at, and then which test pattern, and that way you know you can pick up these leaks in addition to any other signals or carriers that you might be put on the network that, for instance, that you're still monitoring in the LTE band, all right? Generally, the frequencies are the same, right? So we don't need to change antennas, right? So we're still transmitting in that aeronautical band, and we're still transmitting up in the LTE band, right? So we don't have to change antennas or other portions of the system. It's just you have to make sure that you have a receiver that can pick up that particular tag signal, right? However, there is one difference in how we hear this or detect this. There can be gaps in the signal, all right, as the burst round robins through the node. So remember, the controller is telling the different modems, right, when to burst. So depending on where you are in the node, you may not hear a continuous signal when you're actually using your leak detector. All right. So what I'm going to do is I'm going to, actually I forgot to make the point. So that just means that when you're looking for the leaks, you have to move the antenna a little slower. You'll see when we hear the leaks, you can't just go whipping this thing around like, here, because there are little gaps in the signal. So just slow down a little bit, right? As I'm going around, and I'll see it increase and I might see it decrease as I aim my antenna in different directions. I just have to take it a little bit slower. So let's listen to how these things sound a little bit differently. So the first one I'm going to play here, hopefully this comes through properly. This is kind of a standard how the leak sounds. It's pretty continuous. Now it goes up and down based on the strength, but you can see it's a continuous tone. Okay? As it picks it up. All right? Now, let's go and let's hear what it sounds like when you're listening to an OUDP signal.
Okay.
Sounds like Pac-Man.
There's 2000.
See, it's coming and going, and that's as it's getting a burst from the modem.
Yeah.
All right, so this was actually, they're looking for a leak. So let's go back. So this is how you standard one you hear. Oh, I hope this is coming through. Let me get done here.
Eric, it is coming through.
Great, that's good to hear. Glad you guys can hear it. And then let's go back to the OUDP. See how it's different? And because of that, you do have to just slow down.
There's 2000. Yeah.
Okay, so that's kind of a difference in how we have to work and monitor the leaks. All right, so we're already to the summary and review portion. Isn't this great? This is going to be quick. So high split requires that we make changes to how we monitor things because of the aeronautical band. All right, the aeronautical band basically moves from the downstream portion of the network to the upstream portion of the network. All right, so we have to make that change. Right. The cable modems, we start using the cable modems to transmit the leakage carrier using this OUDP burst technology. All right, so that's what the modems are generating. So some of the signals come from the hub site, a lot of the signals are coming from the modems as well, and we're using both to be able to detect the leaks. And while there's enhancement might be required to the leakage detector to pick it up, most other aspects and the techniques that we use to find and fix the leaks are pretty much the same. The only one I would stress is slow down. You just got to slow down a little bit because of that can be those gaps in the signal. All right, so that's kind of a review. So now what I want to do is do a little review quiz. So we're going to go through 5 questions. So as we do the questions, I want you all to write the answers to the questions on the back of a $20 bill and then send that to me when you get done, and I'll be happy to check out and make sure that you all passed it very properly. Just kidding. We're not going to take a poll or anything. So as we go through these, just yell the answer out into the ether as to the answer of each one of them. So question number 1: when switching to a high split network, there's no need to do leakage detection anymore. What does everybody think? Yell it out into either. True or false? True or false, when switching to a high split network, there's no need to do leakage detection anymore. I hope you all said false. Since we're still using the frequencies, we're just using them in the upstream rather than in the downstream. And as we are the secondary user, we have to, by law, continue to monitor the signals in the network. We have to make sure that we're not leaking those signals out. All right, that was question 1. So question number 2. When switching to a high split system, what moves from the downstream to the upstream? Is it HBO, the aeronautical band, OUDP test bursts, or the LTE band? Yell your answers out into the ether. The answer is the aeronautical band. That's the one that's moving. The aeronautical band is from 108 to 137 megahertz, and it's in, it's moving into where the high split is at 204. So that band, as well as, by the way, the FM radio band, that also is now in your upstream rather than in the downstream. So that is another point of having to make sure that the networks don't leak because of the FM. Obviously, there's a lot of FM signals out there. So that's another impact of moving to a high split network. All right, let's go to question number 3. What is used to transmit the OUDP signals? My truck? The nodes? The CCAP or the CMTS? Or the cable modems? Hope you all got this one. Yell it out into the ether. It's the cable modems. The cable modems are what's creating the signals. That's what's transmitting. It's again, the DOCSIS specification defines the burst, right? The OUDP burst, and that's used, that we can use to properly do the leakage detection at our lower frequencies. All right, question number 4. Every cable modem can transmit an OUDP signal. True or false? Hope everybody's got the answer. The answer is false. Not every modem can do that. Only DOCSIS 3.1 modems are capable of transmitting, or in the future, DOCSIS 4 modems that are capable of transmitting the pulse, the burst. All right? So not all modems will be generating the signal. However, we've all got enough 3.1 modems out there that it shouldn't be an issue. They're just about everywhere. And then question number 5. When detecting a leak in a high split node using the OUDP, it will sound like what? A steady tone, Queen's We Will Rock You, a stutter tone, or a slow warble? The answer is a stutter tone. Remember, it bursts, it's coming, it's going. It's that deet, 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 deet. All right? So this is, and depending on where you are in the node will depend on, to some extent, how steady it is or how much kind of gaps there are in it. All right? So there may be gaps, right, when you're using ODP, as opposed to when you're doing conventional, it's more of a steady tone. Okay? All right. So that ends my pre-prepared portion of this, of going through OUDP and high split. Do we have any questions? I don't know if we want to open this up for people to ask questions or if they type them in. Any questions?
Either way, what people are comfortable with. So type them in, or if you guys want to ask them, go ahead.
I baffled everybody. I can't see the chat. I'm trying to figure out how to get to the chat. No questions?
So one from the chat is, how well does the OUDP burst correlate with a CW carrier? Thank you, Ron.
Correlate. So in other words, will it give you the same directionality or the same information that you got with the CW carrier that we used before? If that's the question, I think it's very similar. I think it would be very similar, that it would correlate very, very well with the conventional CW carriers, or the carriers that we were, to tag carriers that we were putting on the network.
Eric, it's Ron Rannick. I'm the one who asked that question.
Okay.
The question really focuses around, let's say you could get a modem to transmit a CW carrier at a certain power level, and then you switched it to OUDP burst. Would the leakage detector, or would the correlation between the measurement of the field strength for a CW carrier on that frequency at a given power be the same as an OUDP? I'll get this right. OUDP burst, same frequency, and we'll assume the same power.
Yeah, so first thing we all need to do is, whoever invented the acronym of OUDP, we need to slap them, because it's really hard to say a lot.
Yes, yes.
So I don't know who that was. Might have offended somebody on the call here. I think it'd be similar. I don't know, Mark or Dan, do you guys have anything?
Eric, I can chime in here.
Sure.
Ron, the meters are calibrated to provide a field strength measurement based on the bandwidth of the carrier itself. So typically 6 megahertz wide carrier. So it'll take, in either case, it'll take either the dual CWs and correlate to the 6 meg carrier and the 1.6 meg carrier of the OUDP, it will correlate the same way to the 6 meg carrier.
Okay, thanks for that clarification, Mark.
Yep.
So James, I've tried to unmute you without success. So James has a question. Putting the FCC requirements aside,
Can you hear me?
Oh, now I can, yes.
Okay, thanks. Yeah, so being the software guy here and not the RF guru like the rest of you and Ron. So putting the FCC requirement aside, so if I've got a shielding break, basically an integrity break in the cable, do downstream test signals leak the same as an upstream OUDP signal? I mean, basically, do frequencies or do different frequencies leak differently, or am I going to find it equally on using a downstream test and an upstream test?
The frequencies will leak the same. So in other words, it doesn't really matter which way I'm transmitting from, shall we say. If I'm transmitting at 139 meg and I'm from either way at 139, it will, shall we say, propagate or leak the same. Now, different frequencies definitely leak differently, right? So if I'm at a higher frequency, I will get different characteristics when I have that leak, both in how I detect it, how it propagates. So you can actually have a damage to the cable, right? It's possible you have a damage and it's of a certain shape, and you will find, for instance, that the high frequency may leak more than the lower frequency, even though it's the same break in the cable, or vice versa, right? So it varies. That's why you need to monitor at both frequencies, because not all leaks are created the same, right? So you actually have to be detecting them in these bands to make sure that you can't just like run one carrier and say, oh, my system's tight, right? Because we are using such a wide variety of frequencies, from 10, 12 megahertz all the way up to 860 gig. We're going above a gig. That these leaks actually are different. That's why you have to have multiple carriers to be able to detect properly, ensure the integrity of your system, and detect if you have any issues.
Great, thank you.
Yep. Any other questions?
So Nick,
Nope.
So Nick, you should be able to unmute yourself, I believe. I hope. Maybe not. So Nick had a question. Can we expect each 3.1 modem to transmit only twice per second, or more, or much more, depending upon how many modems are in HS mode?
Keep me honest here, Mark and Dan, but I believe it's based on how many modems are in that node as to how fast it round robins. I think it's doing it continuously, right, Mark and Dan? It's doing it continuously across the node, so I would think more nodes it would take a little longer to get through them all. Is that true?
That is true. There is it does depend on how many modems and how the settings are. But yes, you'll get at least a couple full round robin cycles in, even if you have 300-400 modems out there. It's pretty quick.
And that's a couple you'll get a full round robin every second, or within what duration, what period of time?
Within a second, you'll get at least a couple round robins.
Good question. It's how fast he gets through them. Any other questions?
I think thanks everybody for today. I thought I saw like an additional question, but and I'm sure that Eric will be open to other questions we have after the fact. But thank you again for joining. Also, just a note, I did want to say we are finalizing the plans of our Rocky Mountain event. It'd be June 20th to 21st. So keep an eye out for that. We're looking forward to seeing everybody, and thanks again for joining. And thank you so much, Eric, for your time. This was great.
Very good. My pleasure. Thank you, everybody.